Recording started.
Okay, girls. Today, inshallah, I'll try to finish your chapter 4. Okay, the chapter 4 is data mining and knowledge discovery. Okay, so here, see, this is the chapter name, data mining and knowledge discovery. Okay, first coming to this chapter inside, what are the major topics is there? Okay, first we have to discuss about what is the data mining, why data mining, and what is the motivation of data mining, and this one, data mining is a knowledge data discovery process. So this is the, what is this process inside the data mining, what is knowledge data discovery process, and inside the data mining, and what kind of data we have to dig, and what are the major data mining tasks, and what is the definition of data pre-processing, and what is the description of data pre-processing, and what are the major tasks present in the data pre-processing. These all we will discuss in the chapter 4. Okay, first coming to the why data mining. Normally we know that searching the data, and we know that storing the data, and we know that what is how to find the data. All these things we know. If you have a simple data, like a very small data, if you have a simple data, very simple data, that time you can use searching data or finding data tool, anything like that. Suppose you have a very huge amount of data. Very huge amount of data means very big data. So that data contains maybe major sources and number of collected informations and number of data warehouses together, like that. If you have a huge amount of data, that time you need compulsory data mining. First of all, data mining. Mining means it's a searching. Mining means it's a one procedure, one kind of searching. Here, see this one. Mining means like digging. Also called as searching. Okay, so if you have a huge amount of data, you have to use data mining procedure. Okay, so see here they gave some two small examples. Here this one, very simple examples they gave here. Okay, business and science. Business and science. These two are the simple examples they gave. Simple examples they gave here. Okay, so first coming to the business. So business example, you can take the business as a bookstore. Okay, so bookstore. Inside the bookstore, we have so many types of books, different kinds of books. Okay, like story books, novel books, and subject books, computers books. Like that, we have so many books available in the bookstore. So that time, suppose the bookstore wishes to make recommendations to the customers based on other customers' previous purchases. Example, web, e-commerce, transactions, stocks, etc., etc. So how we know about that this book is very good and this book is not good? Like that, how we know? Based on the previous customers' purchases and feedback in the websites. Web means websites, and e-commerce transactions. E-commerce means online transactions, online shopping and online, like that. Example, online bookstore. Okay, so based on that online bookstores, we will understand that this book is a very good book and I have to take this book. This is one kind of digging. Digging means searching. You are searching the previous customers' purchases, how they took, how they gave feedback, how the book information, like that you are digging. So you, after finding one final decision, then you will take that book. Okay, this procedure normally it is called as a data mining. Let me discuss in the next slide what is the data mining, how we can proceed data mining, how we can use data mining if you have a big amount of data. Okay. Then another example they gave here, science. Science is another example. For example, see here they took a bioinformatics lab. Okay, so in that informatics lab, okay, normally like a chemical lab, bioinformatics lab, in that lab they want to find a DNA similarities among the different organisms like sensors, bioinformatics, scientific simulation. By applying all these things, by applying the sensors, by applying the informatics, by applying the scientific simulations, they will find DNA similarities among the different organisms. Like for example, father and mother have a same DNA. Like that, they wish to find the similarities. Means same DNA in the different people. Okay. Then coming to the next example, another example, society. See here the society. Society means everyone will remember immediately, like social networking. Okay, so any company like marketing companies or research company, any companies in the social networks, everyone will remember that society means social networking. So in the social networking, what are the availabilities we have? First one is the Facebook, YouTube, and Instagram, Snapchat. Like that we have so many different kinds of social networking websites. So by using that social networking websites, we will identify the most influential users. Okay, so how maybe one company is there, like a beauty company, like face powder or face cream, like that beauty powder company is there. So how you will find that beauty company is maybe very good product like that, using the social networks. Okay, so see here in the social networks they gave, we are drowning in data. See, we are drowning in data, but starving for the knowledge. We are seeing everything. That means inside the Facebook, inside the YouTube, we are seeing everything. We are seeing all data. But we are searching for only the knowledge. Knowledge means what you want exactly. Okay, so after searching the knowledge also, you can think about that knowledge. It is a difficult, or maybe the size in more size in the data, like that. Maybe number of data analysts remains relatively small. Everything you can identify after starving the knowledge. Okay, then here we use some traditional techniques. See this one, we use some traditional techniques to find out what we want to identify exactly, what we want exact knowledge. So here some traditional techniques will be simply inapplicable. We need to find efficient ways to analyze the vast quantities of raw data to extract the knowledge. Normally, these traditional techniques we can use it if your data is very small data, like 100 GB, like 10 GB, like that. If you have very small amount of data, these traditional techniques will be applicable. But if you have a big amount of data, that time you need some efficient ways. These traditional techniques are inapplicable. That time you need efficient ways to analyze your data. Okay, after analyzing your data, then you can find what data you want and you can extract the knowledge. These three are the examples of data mining. Why? In the business, in the science, in the society. Okay. Then coming to the, see here, why data mining? Why we use the data mining? See, normally the data is scattered over the network. That means scattered over the network. That means not in the proper order and not in analyzing order, like this. data is not available in the network. All the data will be some places that will be scattered. Scattered means here one data, maybe another data is in the last page, like that. So that's why we have to use data mining. Suppose you want to find the data you need. Data is scattered over the network. Second one, I can't get the data I need. Need an expert to get the data. Suppose you didn't find what you want exactly that time. You need an expert to get the data. Okay? And I can't understand the data I found. Available data poorly documented. Okay, you find some data, but that is poorly documented. That time you need data mining. And suppose you find the data, but you cannot use the data. The results are unexpected. That time you need to transform data from one to another format, like mp3 to mp4, like that. That time you need a data mining. And now coming to what is data mining. So what is data mining? Okay, here we have several definitions of data mining. First one is extraction of interesting, non-trivial, implicit, previously unknown and potentially useful. See, extraction of interesting patterns or knowledge from huge amount of data. So whatever it is a non-trivial data or implicit data or previously unknown data and potentially useful data, what type of data, but you want to extract something what you want from the huge amount of data. Okay, that is one definition. Okay, see here, note it down, girls. Here this is one definition, and another definition is exploration and analysis by automatic or semi-automatic of large quantities of data in order to discover meaningful patterns. That means, suppose here you have maybe a huge amount of data, that is a large quantity of data you have. So if you want to explore the data or if you want to analyze the data, whatever it is, by automatically or by semi-automatically, that time in order to discover a meaningful data from the huge amount of data, from the large quantities of data, by using the automatic analysis or by using the semi-automatic analysis, discover means finding the meaningful pattern, meaningful data, what you want. That is another definition. Okay. Coming to the another definition, we have three definitions, right? So maybe this three definition, 1 mark, 1 mark or 2 mark, like that. Anyone? Okay, I will tell that. Which definition you want to write, I will tell everything clearly. Okay? Coming to the another definition, knowledge discovery in databases. So see here, girls, suppose from these two you have to write. If I ask what is data mining, define means first one, this one and this one you can write. Two definitions you have to write. Okay, these two definitions you have to write. Suppose if I ask define the data meaning in base of using the knowledge discovery, this one, using this KDD. If I mention the KDD means you write this definition. Okay, so KDD means knowledge discovery in database. Okay, knowledge discovery means mining. Okay, so knowledge discovery in database. So see here, in the knowledge discovery database, knowledge extraction, data pattern analysis, data archaeology, information harvesting, business intelligence. These are the different types of knowledge discoveries in the database. Okay, so only girls remember this and these two are the definitions, and this is the procedures, mining procedures of your what it is called, data mining. This is the mining procedures. First one is knowledge extraction, this one. Then second one is data pattern and analysis. And the third one is data archaeology. And the fourth one is information harvesting. And the fifth one is business intelligence. So the question for this is knowledge discovery in databases is, so write some techniques in knowledge discovery. Okay, so write some techniques. This is the techniques, data mining techniques. Girls, note it down. This is the data mining techniques. First one is knowledge extraction. Second one is data pattern analysis. And third one is data archaeology. Fourth one is information harvesting. And the fifth one is business intelligence. Okay, these two are the definitions and this is the techniques. Okay. Now coming to the next one, data mining is a confluence of several disciplines. See, that means data mining we can use in several disciplines. Disciplines means like several subjects, like statistics, like algorithms, like machine learning. You can use data mining in all over the subjects. So see here first, this is the data mining, statistics, database technology, algorithms, machine learning, visualization, and some other disciplines, and some pattern recognition. You can use in this confluence of several disciplines. Okay. Then coming to the data mining applications. First one, data mining applications. Okay. So this is the data mining applications. First, coming to the first application, database analysis and decision support. Data mining application, first point is, whatever the data you have to analyze the data and you can take the decision. First application. That should be important in the data mining procedure. The second one, market analysis and management. Okay, so market analysis and management. That means target marketing, customer relation management, market segmentation. Market analysis. Market analysis means, suppose consider an example of statistics. Okay, so statistics normally we can use for analyzing the profits, loss, all these things in the business. Okay, so if you consider example statistic analysis, first you can analyze the market, how it is. So what is the target of marketing and what is the relation between the management and customer, that you have to analyze first. Okay, then coming to the second one, risk analysis and management. Okay, risk analysis and management. So inside the risk analysis, forecasting, customer retention, quality control, and competitive analysis. Okay, so suppose if you have any problems in the analyzing data, that you have to clear. And also you can check the quality of data, and also you can control the data analysis. Okay, this is the third example. Then coming to the fourth one, fraud detection and management. Yeah, this is a very important, fraud detection and management. Fraud detection and management means, see here, write some techniques in KDD means you have to write the 4 techniques. Okay, in the first slide it is there, right? The techniques you have to write. Okay, then coming to this one. 1 minute. Yeah. Okay. Yeah. Then fraud detection and management. Fraud detection and management means, see here, you have huge amount of data. Very, very big, huge amount of data. That time, what you want to do? No, not this one. This is not good. Minute, girls. This I want to make like this. Okay. Now Now you are seeing, right, clearly? Because I want to see some girls asking the queries. So why I am making this one like this? Okay. June 100%. Okay. Yeah. Now it is good. Okay, now coming to the fraud detection and management. Fraud detection and management means you have a huge amount of data. From that large amount of data, which is required for you, exactly what you want, that you can carefully observe and carefully find out this is the original data or maybe this is the fraud data. Like that you can analyze, then you can choose your knowledge. You can find your knowledge from the huge amount of data using the data mining application, data mining procedure. Okay, then coming to another applications, we have some another applications, text mining, okay, and web analysis, intelligent query. Yeah, see here some other applications. First one, text mining. Text mining means normally we can use the text in the Gmail or emails and some news groups like a WhatsApp, like a Snapchat, like this. Suppose your friend sends a message to you long back, but you want to find out that message. So what you will do? Simply you will open the application of WhatsApp, then you can type the message. You remember a little text. So you type that message in search box. Automatically what the message your friend sent to you, that will extract clearly. Okay, that is a very basic and simple example. Okay, then web analysis. Web analysis means best example is like online bookstore, online shopping center, like this, best example for the web analysis. And intelligent query answering. Intelligent query answering means like a blogs. Like a blogs. Suppose some people will ask the questions and the blog people who knows the answer very exactly, very clearly, they will give the answering. Okay, and next coming to the architecture of simple data mining. Architecture of very simple data mining. See here the architecture how. Yeah, see architecture of very simple data mining. First, this is a big data. Okay, this is a here don't have any pencil, pen like this. Okay, no problem. Okay, so here this is the data. So the data will be present in the worldwide and some other databases and the data warehouse and database. Okay, so this is a huge amount of data. That means very big amount of data here you have. Okay, so from this big amount of data, you want to find a small information. So that small information is called as a knowledge. Okay, so for example, from this World Wide Web, you want to find a friend in a Facebook. Now let's take example of Facebook. Facebook data is very big data. So from that Facebook data, you want to find your friend Facebook account. So that time what you want to do? First, you have to perform data pre-processing. Data pre-processing means from the huge amount of data, you have to clean the data. Suppose with your friend name so many people is there. Okay, so that you can clean the data and then you can write some different things like integrations, and also you can select the people, maybe she is your friend or like that, and you can do the transformations, etc, etc. Okay, after data pre-processing, you will find some database or some data warehouse server from this entire data. Okay, so after finding one database or one data warehouse server, you can apply the data mining technique. Okay, so here apply the data mining engine. Okay, so if you use the data mining engine, you can find exactly what you want. Okay, after finding that exactly, pattern means data, exact type, exact style. Okay, after finding that, you can save for the future purpose in the knowledge base. Okay, for the future purpose in the knowledge base. Then you can interface, user interface. Okay, then it will get to the people who are searching for the data exactly. Okay, so this is a very simple architecture of simple data mining system. Okay, then coming to the next one, data mining using the knowledge data discovery process. Okay, so see here, knowledge data discovery process. So this is the diagram for the knowledge data discovery process. First, input data. So what your idea, your decision, what you want to find exactly, that you can give input. So after giving the input, that data KDD process will perform the data pre-processing. After data pre-processing, here see, you can observe one thing, girls. Data pre-processing involves, it contains the feature selection, dimensionality reduction, and the normalization and data subsetting. All these procedures will involve in the data pre-processing. Okay, after finish the data pre-processing, you can implement data mining. So after implementing the data mining, you will get some exact knowledge or exact some information. So on that some information, post-processing, whatever you extract using the data mining, on that data you can apply the post-processing. So post-processing involves filtering the patterns, visualization, pattern interpretation. The same style of data, maybe 100 data or 200 data that will be extracted from the data mining technique. So after getting that 100 and 200 same styles, you can filter the patterns. So what you want exactly, you can filter all these things by using these techniques. Filtering patterns, visualization, pattern interpretation. After applying all these techniques, you will get exactly what information, what knowledge you need. Okay, so this is the knowledge data discovery procedure. Okay, then coming to the next one, steps of knowledge data discovery process. First, these steps, girls, very important. Steps of knowledge data discovery. First, learning the application domain. Okay, so what you are using, that you have to learning the application domain, relevant prior knowledge and goals of the application, what everything you have to learn. First step. Directly you cannot give the input. First you can learn what you want exactly, what are the goals, what is the knowledge you required. All these things you can learn clearly, then only first step you can give the input. After that, creating the target data set. That means data selection. So just here example I told you. In the first step, you choose Facebook. Okay. So in the second step, you choose your friend name. Okay. That is target data set. Okay. Then is this numerical? No numerical, dear. Not numerical. This is not numerical. Just you can write like this as it is. Okay. Then third one, data cleaning and pre-processing. That means suppose your friend name is Fatima. With Fatima, you have so many people present in the Facebook account. Okay, in the Facebook domain. So from all the number of Fatima, you have to clean the data. Who want you exactly? Okay, who want you exactly? That I can't understand. If you write in Arabic, speak me in English, no problem. Speak me, I will give answers. Oh my God, the net disconnected, dears. 1 minute, net disconnected. What is this, teacher? What is this you writing in Arabic? One minute. 1 minute. 1 minute. I will copy and I will see what is this exactly what you are asking me. I am not understanding. Okay. 1 minute. What is this, dear? If you speak with me, I will give answer. Okay. Question of this slide is, what are the steps of KDD process? Maybe see how many steps is there here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here we have 10 steps. From this 10 steps, 1, 2, 3, 4. So 4 steps are very small steps. Okay. So 4 steps have half mark. Remaining steps may be 1 mark, like that. Okay. So like that you can calculate and write the answer. Maybe I will give, this is 10 points, right? So 10 points, 6 mark and 7, 8 mark. Maybe 8 mark I will give. Yes. Write all 10 points for 8 mark. Total 8 marks. Okay. So like this I will give in the exam. Okay. Let me finish first. Data cleaning. After finish the data cleaning and pre-processing, you will get the data reduction and transformation. That means from the 100% of data, maybe you will get 40% of data. Yeah, sure. Inshallah, no problem. We'll give easily, no problem. Okay. I will ask how many points you write, like that also I will ask, no problem. Okay. Don't worry. Okay, after data reduction and transformations, we can find useful features and useful dimensionality, variable reductions, and invariant representation. That means Fatima, like I told you, right? The data target, the data selection is your friend name like Fatima. So your friend full name is maybe Fatima Al-Khatani. But with Fatima Al-Khatani, maybe 100 people is there. That time you can check the father name. So that is, once you check the father name, you will get the exactly what data you want. Okay. After that, you can choose some functions of data mining like summarization, classification, regression, association, clustering. All these things already we did in the lab. Okay. So this classification, regression, association, clustering, by applying these functions, steps. Okay. Summarization, classification, by using these functions you can filter, you can get exact data. Okay. After choosing this data mining algorithm, you can search for the exact name of your data selection. After choosing that, after applying the data mining techniques and all, you can remove unwanted information and you can present the knowledge which is required for you only. Okay? After discovering the knowledge, which knowledge is useful for you, then you can take that knowledge as your data selection. Okay, this is the steps of knowledge data discovery procedure. Then coming to the diagram for data mining using the knowledge data discovery procedure. Okay, first see here the steps. Whatever the steps you are using, same thing here also you can use. First, data cleaning. Okay, this is your data selection. This one is your data selection. Data selection means what data you want? Knowledge. So that knowledge you can select here. So for getting this knowledge, what are the steps? This is the first step. This is the first steps. First step is data cleaning. Okay, so clean your data clearly. Then second step, after cleaning the data, whatever the data will come out, that is extracted, that data you can store here in the data warehouse. From this data warehouse, you can select the data what you want, the task relevant data. That means chosen data. So that data here you can keep. On this data, you can apply some functions, data mining functions like classification, regression, association, like this functions you can apply here in this data. Okay, after applying this data, you will get some patterns, some same type of data like Fatima, like the same type of data you will get. From this patterns of data, you can filter what data you required. So after filtering required data, then you can take it out, you can extract what knowledge you want. This is the procedure for getting the knowledge using some KDD procedure. Okay. Then coming to the next one, data mining. On what kind of data we can apply the data mining applications. Okay, so here we have different types of data, and different types of data can be stored in the different types of data repositories. Okay, so here what are the data repositories we have? Relational data, okay, data warehouse, transactional data, graphical data, sequence data, time series, spatial data, text and multimedia data. So here the question, remember girls, here the question for this data mining, this slide is how I can ask, on what kind of data mining can be? Girls, you can note it down, the question for this slide. On what kind of data we can use the data mining? The question is, on what kind of data we can use data mining? So you can write here various data repositories, and also you can write all these 8 data repositories. Okay. Then coming to the next one. First, relational database. Relational database means, see here, this question I want to write. Okay, I will write here the question, girls. Okay, see here, I will write the question. Okay. Question is, on what kind of data data mining functions can be used? Okay, so this is the question for this slide. This slide, only this slide. Okay, then coming to the next slide, relational database. Relational database. Relational database means you have to remember clearly. Slide number 11. Yeah, same things. What are the steps? See here, like this question. What are the steps of KDD process? Okay, this is the question. Like this only I will ask directly. Okay. Yeah, then coming to relational database. Relational database. Relational database means you can immediately remember that it is a table. Table can contain attributes, that is columns and fields, rows and information, all these things. Relational database means immediately you can remember that it is a table. It is a set of tables, and also the table has, each table has a relation using the different ways. So using the different ways. See here the example they gave here. Employee table, branch table, work table. These three tables has a relation. Teacher, we still in slide 11. Why? Okay, I will wait 2 minutes, no problem. Okay. Now see here, this is example. If you see this example, you can understand very clearly. Here employee table, here branch table, here work table. Okay. So for example, employee is a Smith. Her address is some Chicago, and position is manager. And okay, log out and log in, come again, no problem. Host is passed. Why? Host is passed. Why? What happened, girls? Wait, again I will share. Yeah. Now coming again. Yes, now coming again. Yes. Okay. Now this is a relational database. So see here the example: employee table, branch table, and work table. So employee, maybe here you can write example, take my name. Here teacher Teju. Okay, teacher Teju, address is India. Position is teacher. Salary is so and so. Okay. So here in the branch I can relate it. Branch is computer science. Name is maybe Ahidru Faida. Address is like this. And work, where is the work? He can work, Teju can work for the 2 subjects. Like this. See, for these 3 tables has a relation. Okay. So like this, the relation information present in the number of tables, that is called as a relational database. Now coming to the data warehouse. Already so many times we discussed what is a data warehouse. So inside the data warehouse, we can store the data using the data cubes. Okay, so using the data cubes, same information which is present in the chapter 1, you can write here, no problem. Okay, that is data warehouse. Then coming to transaction data. Transaction data means suppose you will go for the shopping. Okay, to buy a bread, to buy milk, like to buy Coke, all these things. After finish everything, then you will pay the bill, right? You will pay the money to the counter. Okay, after paying the bill, they will give one slip. That is called as a transactional data. That means what item you take, how much item that cost, everything they will write clearly. Example, you write that one, no problem. Okay, so this is one type of transactional data. Okay, then coming to graph data. Here, see this one, graph data. You know the graphs, right? Directed graphs, undirected graphs. We have so many things like graphs. So that example you can take social network. Social network, how it is related. Facebook is related to Instagram. Instagram is related to WhatsApp. WhatsApp is related to YouTube. Like that, you can draw by your own. Okay, that is graph data. And sequence data. Sequence data means like 1, 2, 3, 4, 5, like that. Every data is present in the order. See, this is example. Here girls do one thing, not write same thing, no problem. Okay, you can use any numbering like A, B, C, D, like C, 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 D, D, anything you can write. But this is one style, this is one pattern example. Okay. So sequence data means same letter maybe 2 times or 3 times like that. A, B, B, C, C, like that you can write. Sequence data is in the ordered sequence of events. Sorry. Okay. Then coming to time series. Yeah, time series. See here, time series means today what table, tomorrow what table. Okay, maybe today you have the second hour. Delete graph, yes, no problem. Delete this, no problem. This graph, no problem. You can use your own graph. Okay, you can write your own graph using the WhatsApp, Facebook, relation, like this graph, just edge. Example, see, I will draw here like that. 1 minute. What happened to this? Okay, insert, know this, shapes, use the shapes. Okay, this is Facebook. Okay, then again maybe this is WhatsApp, again then this is Instagram. Okay, and this is the Twitter. Okay, so after drawing like this, you can connect the directions. You can connect like this. This is called a graph. You can write your own graph, no problem, like this. Okay, so this is one graph, but you can write here, this is WhatsApp, this is Instagram, like that you can write. Okay, so delete this big one. This is not clear, right? So you can draw like this, a very simple graph. Okay, then coming to the time series. Time series means best example is timetable. Okay, so the timetable, today what the table, tomorrow what the table, today when your lab, tomorrow when your theory class, like that you can write. So the time series is based on the hourly, daily and weekly. Okay, hourly, daily and weekly. Okay, so if you consider weekly, maybe your theory class will come in the Thursday. Suppose you consider hourly, maybe 10 to 12 your theory class. Like that you can consider. This is example of time series. Then coming to spatial data. Spatial data means there is maps like Saudi Arabia, like India, like America, that you can write example. The spatial data can contain the geographical attributes. Geographical attributes means like spatial coordinates, where the Saudi Arabia is present, how much space for Saudi Arabia, like that you can write. This is a map. Okay. Then text and multimedia data. Text means the numbers and the letters, capital, what it is called, strings, all these things, text data. And multimedia data means it is images, image, videos, audios, and it's GIF files like this. Okay, that is multimedia data. Okay, then coming to major data mining tasks. What are the major data mining tasks. See here, first one, characterization, discrimination. This is the first task, and here in the characterization, in the discrimination, what we will do is generalization, summarization, and contrast data characteristics like this. Example, you can write dry versus wet regions. So here you can say dry versus wet regions means maybe you can take dry region is Riyadh and wet region is Abha. So how you can generalize? Dry means maybe very hot, and it is a very hot area, there is no trees, like that you can write some characteristics. Okay, so to elaborate the characterization, you can write something related to dry and related to the wet regions. Okay, then classification and prediction. Okay, classification and prediction. So whatever the data you have suppose, see here, we have set of records. Okay, so set of records that is called as a training sets. Suppose you have the set of records, that means number of tables. Consider example number of tables. That tables we can call as a training sets. Okay, inside the training set, each record contains different attributes. Different attributes, various attributes. Each record contains various attributes. So not only one table we have, not only one record we have set of records. Inside the set of records, each record contains different attributes. So among which there is a category, there is a categorical, that is discrete attributes referred to as a class. So how can I say example like here, suppose, wait, I will use the shapes. I will use the shapes, girls. 1 minute. Okay. Yeah. For example, this is one record. Okay. And same like that, this is another record. And same like that, this is another record. We have set of records. So inside this record, we have example. I will use another color here. Okay. Yeah. Okay. See this one I will use. There is attribute. This is one type of attribute. And this is another type of attribute. Okay. And that is another type of attribute. And this is another type of attribute. Okay, so see here this is one record, this is one record, and this is one record. So each record contains different attributes. See, this is triangle, this is some line, and this is some star. Okay, so these attributes is called as a class. So by using these attributes, we can perform the classification. Okay, and see here what is the main goal of classification is record, in the given record, predict the value of its class. That means here inside this class, maybe number of values is present like A, B, C, 2, 3, 4 like that. So using this class, we can imagine, we can predict the class, its value of the class. Okay, that is the main goal of classification. Now coming to the prediction. Prediction means whereas classification predicts the categorical attribute values, prediction predicts the numerical attribute values. Okay, that means by using the classification, we can identify this class is triangle, this class is star. Like that we can predict. After classification predicts the class values, prediction can predict the value, numerical value. Maybe this value is 3, this value is 4, like that. What happened again? Again, any problem, girls? Oh my God, net problem? Wait. Okay, girls? Okay, then prediction can find out exact value of the class. Okay, here we can use some regression analysis, that is like a statistical methodology that is most often used in the numerical predictions. So by using the regression analysis, we can predict the numerical value of the presented class inside the record. That you have to remember, girls. So the classification and prediction. How I will ask the question is, girls, definition of classification. Okay, this is definition of classification, and this is definition of prediction. Okay, and this is the goal of classification. What is the main goal of classification and prediction? That you can remember. Okay. Then coming to the next slide. Yeah, cluster analysis. The next one is cluster analysis. Cluster analysis means, see here I will show a small example. All the stars will be in one database. All the stars will be in one database. Like this. Star, another star, star, another star. Okay, make it as a small. Okay, this is one type of data, because this is also star and that is also star. This is called as a one cluster. Okay, another cluster. Example, triangles. Here this, again this, again another this one, another this one, another this one. Okay. Okay, so this is one cluster. How can we say, see here, this is one cluster. Okay, and this is another cluster. Now you understand cluster analysis means, see here, the similarities here, all stars, no matter what size. Okay, here all triangles. This is called as one cluster and this is called as another cluster. Okay, the main goal of the cluster analysis is, suppose these stars and these what it is called triangles together they gave in one database. So you can apply the cluster analysis to separate the similar objects in one side and the similar objects in another side. All the stars in one side, all the triangles in one side. Okay, so this is called as a cluster analysis. So now here, example, they gave an example, medicine example they gave here. See this example description. Cluster analysis may be used to group cancer patients one side and their based on their based on their spatial distribution in order to derive conclusions about the cause of their health problem, their illness. Okay, so example, medicine example means, who has a problem of cancer, they will group in one side. Who has a problem of maybe skin problem, they are in one side. Like that you can differentiate the clusters. Then coming to the outlier analysis. What is nothing but a outlier analysis? Outlier analysis means, see here, a data object that does not comply with the general behavior of the data. Suppose, see, example I will tell. One example I will tell. In your class, all girls are listening class very carefully. Okay, example I am telling, girls. All girls are listening carefully inside the class. But one girl, maybe she is making noise and she don't have interest to listen, or she is doing something like that. Okay, so we can find out she is an outlier. Okay, that means she is just special. Like how can we say, this girl not similar to other girls. That is called as an outlier. Okay, so here example, fraud detection. Fraud detection. Collect all the transactions of credit card holders. Okay, cluster the transactions based on the location and the amount of money spent. Okay, suppose if you lose the credit card, you can, the people can find out and can collect all old transactions where you did the transactions and where you used the credit card. All this type of information they will collect, and they can detect whether incoming transaction is considerably similar to all information or not. Okay, that they can find. Outlier means from the group we have a special person, that is outlier. Okay, that you can remember. Association analysis. So girls, association already we discussed in the lab. So no need here. Okay. So no need. Delete this one. Delete this slide. Okay. Delete this slide. Then this also. This also. This also delete. Okay. This also delete. No need this one. Okay. Then yeah. Objective definition and subjective definition. Okay, these two are the definitions of objective and subjective. Okay. Okay, first coming to the objective. Objective means based on the statistics and structures of the patterns, we can find example, support, confidence, then how can I say, based on maybe good profit, maybe how can I say, you have a good thing, like that. So we can find out this is the objective. Then subjective means based on the description of user beliefs. Description of user beliefs. You don't know exactly what is that, but you believe that we don't know how now we are using, right? Now we are facing one problem, right? Because of the coronavirus, we are sitting inside the class, inside the home and teaching like this. So just we are believing. We don't know how the coronavirus is there. Okay? But we are believing and we are doing something. That is called subjective. Example I am telling. That is called subjective. Okay? Then data preparation for knowledge discovery. Data pre-processing. Data pre-processing. First, I told you in the starting of the class itself what is the data pre-processing. That means you have some amount of data. Using that amount of data, you are going to prepare the stage, preparation stage. Is a data preparation stage before the actual data mining tasks are performed. That means already you extracted some amount of data. Okay, on extracted data you are going to apply some data mining tasks. So why we are going to apply some data mining tasks on the extracted data is to remove the incomplete, to remove the noise, to remove the inconsistent and redundant data, and to reduce the size and the difficulty of your data, and in order to refine the quality of the mining results and to improve the performance of the mining task, that we are going to apply data mining tasks on extracted data. This procedure is called as a data pre-processing. Okay, so see here, no quality data is equals to no quality mining results. If you didn't extract a quality data, your mining results also not quality. Okay, then why we use data processing? Okay, so already this question, which question? This one. This question, same. Data. What is the data preparation procedure for knowledge discovery? What is data preparation for knowledge discovery? The question is this one. Okay, this one. The question is this one. Okay, then coming to next slide. Why we use data pre-processing? Why we use data pre-processing? Already we extracted the knowledge, right? Yes, you have to write all points. 3 points only, right? Only 3 points. Okay, now coming to here, why we use data pre-processing. Normally, data in the real world is very dirty. Maybe the data is incomplete or lacking attribute values or contains only aggregation data or maybe like this. Not exactly what the data is. So for getting the exact data, we are going to use the data pre-processing technique. Okay, so this one, what is a noisy, what is a inconsistent, what is a redundant? Okay, so noisy, what is the noisy? It contains some errors and outliers like this. Example, see, salary is not in the negative, right? Salary is not in the negative values, right? So this is noisy data. That means here it contains semicolons and quotes, minus like this. All these things is noisy data. To remove these noises like this one, we are going to use data pre-processing technique. And inconsistent. Inconsistent means, see here, it contains discrepancies. See this one, discrepancies in codes or names. Example, see this one, age 42 and birthday 030701997. This is inconsistent data. Who name, who birthday, who age, we don't know exactly, right? So to remove this type of information, we can use data pre-processing. Then redundant. Redundant means it contains duplicate records. That means unwanted information. So if you extracted unwanted information, you are going to remove that unwanted information, the duplicate records. So why we are using the data pre-processing technique. Okay. Then coming to the next one, descriptive versus data summarization. What is the meaning of descriptive data? What is the meaning of descriptive data summarization? Okay, so see here, descriptive data summarization. It is a process to perform before data processing. Okay, so data pre-processing is used for removing the noise and removing the redundant data, removing the inconsistent data, all these things. So before that, we will extract some data, right, using the knowledge discovery procedure. So there we can use descriptive data summarization. Why we use this descriptive data summarization means it gives the overall picture of the data. That means overall information, overall picture of the data. So in that data, which data should be treated as noisy, which data should be treated as outliers, that it will describe. Okay, so here descriptive data summarization involves measuring the central tendency and measuring the dispersions and graphical display of descriptive summaries. Okay, so remember girls, here descriptive data summarization can be find out, it highlights which data is a noise data, which data is outlier data, that and all it will highlight. So it will describe. Then remaining how many slides is there girls? Only 15 slides. Let me finish all these things. Okay, no problem. Till time is there. Yeah, here. Remember girls, one thing. Till here, okay. Then here, this slide. Remember, this slide I am going to remove. Okay, this slide I am going to remove. No need this slide. Okay, this slide. Then this also. This also remove, this also remove. Okay, remove from 31 to this also remove, this also remove, this also remove, this also remove. Yes, 31 to 35. Here I will write. Okay. Then coming to slide number 36. Major tasks in data pre-processing. Okay. So see here major tasks in the data pre-processing. First one, data cleaning, data integration, data transformation, data reduction, and data discretization. Okay, so these are the major tasks in data pre-processing. Okay, first coming to the data cleaning. Okay, data cleaning. Data cleaning means you have to fill in missing values, smooth noisy data, identify or remove some outliers, and resolve inconsistencies. That means if data is not completed, you can fill the data and make it as a complete, and maybe data has a duplicate, you can remove the duplicates, and maybe data has some noise information, remove that information. Okay, so this is called as a data cleaning. Then data integration. Data integration. Data integration. Integration means integration of multiple databases, data cubes or files. Maybe same table with different information. That time you can combine the database and make it as a one database, or make it as a which one? Only 31 to 35 slides. I write here clearly, right? Only 31 to 35 slides you can remove. That's all. Okay. Then coming to data transformation. Data transformation. Data transformation means suppose you are using an Apple laptop and you want to send your information to your friend. So that time maybe here whatever the data you are using, that will not support in other laptop. So that time you can make the data as a normalized and you can make a transform of your data. Okay. Then data reduction. Data reduction. Data reduction means reduced representation in the volume but produces the same or similar analytical data. That means suppose you have a very big file. That file you want to transfer. Example I will tell. Like WinZip, WinRAR you have, right? So if you want to send huge amount of data, you can combine all data in one file and transfer to your friend. That procedure is called as a data reduction. Then coming to data discretization. Data discretization. Discretization means it is a part of data reduction but with particular importance, especially for the numerical data. Okay, especially for the numerical data. Same like a data reduction, but data reduction can be applicable for all type of information. But this data description is applicable only for the numerical data, especially, not only, especially for the numerical data. Yeah, here see the data pre-processing task in the form of cleaning. Okay, so see this is before data. Okay, you can clean this one. This is all unwanted data, right? Okay, you can clean and make like this. Integration. So see data, this is one data, this is one data, and this is one data, but similar information. So you can combine these three and make it one. Then next, yeah, okay. Then data transformation. Data transformation means see here. Maybe this -2, 32, 100, 59, 48 like this. So same data but you can transfer in the supported thing like 0.02, like 0.32, like 1.00 like this. So you can transfer the data from this type to this type. And the data reduction. See here, data reduction. You have 2000 files, 2000 text like this, and here 126. So if you want to send this, you can compress this data and make like this and send the data. Okay, so this is a reduction. Here the data is in a big in size. Here the data looks like a small in size, but it contains all similar information of source. Okay, then yeah, missing data. What is missing data? How missing data can find out? Okay, so first one, missing data. See here, data is not always available. Example, many tuples have no recorded value for several attributes, such as customer income in sales data. Okay, so sometimes data will be missed, like spelling. For example, your name is like FATHMI, like that. Maybe some data is missing, HM missing. Then they wrote your name without H and without M. That is missing data. We can find out like that, missing data. Okay, why missing data? Maybe due to inconsistency with recorded data, maybe data not entered correctly, maybe misunderstanding, and maybe certain data considered important, or maybe we can think this is not important, like that. That times also you can miss the data, and maybe not registered for the history or changes while doing changes of data, like that. That times missing data will be happens. Okay, then how to handle missing data? Okay, so how to handle missing data? Here you can write your own points also. If you understand what is the missing data, you can write how to handle missing data. So first you can think what to do with missing values. First you can observe what to do with missing values. Suppose maybe one letter is missing, you can observe maybe meaning will be changed or meaning same remains. Like that you can observe first. Then ignore the record. Suppose if you don't want that missing data information, just ignore that. No need to modify, no need to integrate again. Then another thing, fill in the missing value manually. Suppose this is important means, suppose the missing value is important means you can fill with manually. Okay, then use some attributes to fill the value. Use some attributes like a copy paste, like that. Then use the most probably value to fill the missing value, like extra tools, decision tree, Bayesian formula, maybe needed to compute the most probable value. Okay, then yeah, see here example of missing value. See, this is your data. Here missing, what is the income? This is missing, and team, this is also missing. Okay, so for this missing values, if you think this person is important, you can fill with manually. Otherwise, you can ignore this record. You can ignore this record, like that. Okay, then yeah, how to handle noisy data. Noisy data means it contains some errors and outliers and some unwanted information. Okay, so these unwanted information you have to make it as a smooth, and you can removing, like updating, like adding, anything you can do. Then you can make it as a clear data. Okay, then binning. See here, what is a binning? What is a regression? What is a clustering? This is the definitions, girls. Okay, how to handle the noisy data means only till here. Till here, how to handle the noisy data. Okay, then this I will ask like what is a binning? Definition, define. Regression, define. Clustering, define. Okay, you can use to handle the noisy data these three procedures. Okay, first one binning. First sort the data and make it divided into two parts, like a bins. Folder. Binning means folders. One folder, one smooth folder, one unwanted folder, one median folder. Like that you can divide your data into different categories. Then you can apply the regression. So smooth by fitting the data into the regression functions. Okay. Then you can make clustering. Detect and remove the outliers. That means similarity data will keep one side. Outlier data you can remove by applying the clustering. Okay, so like this we can handle the data. First we can know that We have to understand what is an IC data. After understanding and after getting the IC data, you can make the performance of binning. So binning means you can sort it out the data and make it into the partitions of the data, like a smooth data, medium data, and boundary data, like that, any kinds of folders. After that, apply the regression technique. That regression techniques can be used to smooth by fitting the data into the regression functions. After finish the regression technique, apply the clustering data on the regretted data. After applying the clustering application, you can find and detect the errors and outliers, and you can remove that outliers. Okay, then correct inconsistency data. Okay, girls, write it down here. This I will ask for the true, false, and fill in the blanks. Correct inconsistent data. This slide I will ask only true, false, and fill in the blanks. Okay. Then, yeah, this no need. This also no need, and this also no need. Yeah, till 41 you can study. Yeah.